Uh, all right. Okay. Right. Okay. So give me a small thumb. Just put a small thumb with my voice and video both okay. Give me a small thumb. Give me a small thumb. Right. All okay. Right. All okay. Right. Okay. Superb. Okay. So now this idea, right? Okay. First story. Give me 1 second. Okay. Right. Okay. So maximum till 7 o'clock today. Right, normally this recap class is on online. If it is online, recap class is on every Monday 3 p.m. to 5 p.m. only, but today I could not start at 3 p.m. exactly. That's why I postponed it to 5 p.m. Okay, no, right, okay. Now this recap class is mainly for the students who willing to do A-level maths and streams after their all results came, because there are some students among you, right? Till the result comes, they don't go to any A-level classes, right? So I will explain what we are going to do in this recap class and what's our plan in this recap class. I'm explaining, right? Okay, quickly explaining, and today we'll start our work. Okay, right? Okay. All right. One last time, just put some thumbs whether my voice and video both clear. One last time, just put a small thumb whether my voice and video both clear. Okay, both clear, right? Okay, right? Okay. Now, okay. Now, if you want to ask something, if you want to clarify something, what you want to do is, uh, you want to reply to Sulaiman sir, what shall I do if I rename my name? Okay, right. All right. Okay. Okay. Now, if you want to ask something, if you have any doubt to be clarified, then what you want to do is reply to Sulaiman sir. Okay. Don't reply to this video streaming account. Don't reply to Aurex Academy. Reply to Suleiman sir. Just go and search the people in that session. Then you can see Suleiman sir reply to that chat. Any doubt, any problem, any issue, anything. If you want to ask from me, then you can reply. Okay. That story is also okay. Right? Okay. We will start the idea. Now what shall I do? I will share the PDF. Today our plan is, today we are doing 2 chapters parallelly, 2 sections parallelly, because I will tell you the idea. Okay, I'll share the link to other groups also. If I share the links to other groups also, right. Okay. All right. Okay. Okay, give me a few minutes. Give me 1-2 minutes. Okay. Right, me? Okay. All right. Right, all right. Okay. Okay, give me 1 second. All right. Okay. Right. All good, ne? All good. Now, you all know that A-level started in March. A-level started in March. I think we started our classes in March, if I can remember. Right? Now, this is March, April, May, June. Right? March, April, May, June means July. This month is July. Now this month is a new month. It is July month. July month. July month. So then, so far, what we have covered already, since we started the classes in March, the sections we covered already for 2028 batch are, right, Unit 1 in my classes. In my classes, Unit 1, we covered unit section. That's a small basic section, not a big deal, very basic section. We covered units, right? And Unit 1, we covered dimensions. That is somewhat important. Then units, dimension section is somewhat important section. Today, we are going to start our classes from dimensions. Dimensions, I don't follow the order. I prioritize what is important, and according to that priority only I am teaching. Dimensions. Dimensions. This section also covered. Right? Then Unit 1 measuring instrument section. Unit 1 measuring instrument section. Okay? Measuring instrument section. Measuring instruments. Measuring instrument section so far. We covered, now there are 4 practicals coming under measuring instruments mainly. Then we covered vernier caliper theories, completely we covered. Vernier caliper and micrometer we completely covered. Vernier caliper, micrometer completely covered. But we have to do spirometer theories and traveling microscope theories we have to do parallelly. We are doing this section. Vernier caliper theory is done. Vernier caliper. Vernier caliper. Then micrometer theories we completed so far. Micrometer. Micrometer fully done. Right, me? So I want to teach for the people. Still I haven't done spirometer theories, I haven't done. And I haven't done this traveling microscope theories also, I haven't done so far. That's all. This is what we have done so far in Unit 1. Right? Okay. So today we are starting the lesson from not units. Normally we start the syllabus, we are starting from units, but today we are starting from dimensions. Right? Because dimension section is really important. to understand the story, okay? Right, also we started unit 2 also for the 2028 batch students, right? In unit 2 what we covered so far, unit 2 we covered so far vectors, very important section, vectors completely discussed, vector section completely done. And then linear motion completely finished. This is one of the core sections, very core section. Linear motion fully done, linear motion is finished. Unit 2 we talked about, I think recently, I think we finished vertical motion under gravity. Vertical motion under gravity theory fully finished. Vertical motion under gravity, okay, under gravity fully finished. And then this month only, in July only, we just started projectile motion. Right, the current lesson ongoing in our 2028 theory, online and physical, all the classes, we just started projectile motion, one of the difficult concepts. Section is somewhat complex, not difficult entirely, can understand, but somewhat complex, some complex story, complex. Right, projectile motion is somewhat complex story. This is what our ongoing lesson. Obviously, if you are starting to learn physics from this month, right, without knowing, without going for a good recap class, definitely you don't understand the lessons. That's obvious. Right, obviously, obvious. Right, projectile motion. So I will tell you the plan briefly. I will talk to few minutes, okay? I will talk a few minutes and then I'm starting lesson. I also don't want to talk actually. But have to talk somewhat, because what we have done so far in our current theory class and in recap class, what we are going to do, how we are going to do, how long are we going to do this story, I want to explain properly, no? Then only you get the idea. If not, you also don't get the idea, no? Therefore, I'm taking some time, I don't know, some time, and I'm explaining the idea, projectile motion. This is our ongoing current lesson, projectile motion. So that means for this around March, April, May, June, for the last 4 months, you completed for 2028 batch students units, dimension, measuring instrument, only vernier caliper, micrometers, vectors, linear motion, vertical motion under gravity. You just start projectile motion. Okay. So under this recap class, even though it's a kind of new batch, under recap class, my target is, I have the recordings. Right, for the last 3 to 4 months recordings I have. If you request, I can provide those recordings, no issue, I can provide it. The problem is, there are some students among you, right, they require a kind of better what if you can explain all the previous sections very quickly. And quickly means not we are going in a very fast way, not like that, right, not very slowly, right, in moderate speed. What if you can cover the previous chapters you covered already for 2028 batch under recap class? Because of that story only, I am in the recap class. So under recap class, what I am doing, all these chapters I covered so far, I am going to redo once again. But there is one story I am not doing very slowly, I am doing somewhat moderate speed. But don't worry, anyone at any level will be able to understand every story I explain clearly. So then my target is, we took 4 months to complete these 6 chapters, right? We can't continue recap classes for 3-4 months, we can't do that. My plan is maximum. Now today we are doing 2 hours. I will decide that if I require more hour, I will increase the duration. So what I do is maximum July month and August month. By the end of August, I want to complete these chapters, 1, 2, 3, 4, 5, 6 chapters. Right, so then you will have a problem that, okay sir, then we are joining the recap classes, then what about the current theory class? Students who are joining for the 2028 recap classes, they should join for the current theory class also. But remember now, we don't charge separately, it's completely free. People who join for the theory class, recap classes, fully free. Okay, fully free. Okay, no, fully free. Okay, so then so okay, right now you are telling currently you are doing projectile motion, and how are we going to understand this lesson without knowing these lessons? You are telling projectile motion interconnected with linear motion and vertical motion. Without knowing these two chapters, how are we going to understand? How are we going to understand projectile motion? That's a good question. Yes. Without knowing these two sections, you are not able to understand projectile motion lesson and thereafter. Okay. Right. So what I'm doing is, in my recap class, I'm starting dimensions parallelly with linear motion. Right. I'm starting dimensions parallel with linear motion. Right. Then this week, tomorrow, not tomorrow, Wednesday. Wednesday is our online. If I tell the timetable, normally 2028 batch theory classes are on Wednesday. Right, 2028 batch theory class is on Wednesday. Wednesday, this is the permanent time. Wednesday 6 p.m. onwards. Now currently we are doing 6 p.m. to 10 p.m. Right, with the time after 6 months later, after 1 year later, it becomes 10:30, 11. That's how it's going. This is our permanent theory class time. But recap class time is a temporary. Recap is class is a kind of temporary class. Recap class is a temporary class that we are doing on Monday, 3 p.m. to 5 p.m. 3 p.m. to 5 p.m. If you require, we can take it to 3 p.m. to 6 p.m. No issue. No issue. This recap class continues maximum 2 months. Within 2 months, somehow, I will explain all these theories properly. Don't worry. Don't worry. I am doing somewhat faster, but don't worry. I will explain all theories properly and I will complete these 6 chapters. Right, maximum recap classes will remain for 2 months time period. By the end of August, my plan. It can deviate sometimes. My plan is within 2 months, I want to cover the story. I can't take too much of time to explain stories. Okay, idea okay. The next story is, so if you join for the theory class, you get free access for recap classes. Right, we are starting the paper class. Okay, 2028 batch people, we are starting paper class from today onwards. Paper class is on Monday, today, 9 p.m. to 11 p.m. Okay, paper class. Our plan is these days we are discussing all the sections we covered. We are discussing past paper questions and some model paper questions associated with these sections. Right? Okay, that story is okay. The next story is normally every month we are providing all the tudes. We are posting all the tudes to your home. Right, for an example, now this month we are doing projectile motion. This month we are doing motion graphs. Right, if we have time, we are starting next chapter. Relative motion also we are doing this month. Projectile motion, motion graphs, relative motion. If we have enough time, then we can start Newton's forces and Newton laws. But I don't think we have time. So that tudes. Right, and also paper class tude. People who are coming for the theory class, paper class tude we are provided to your home free of charge. That is one story. But if you require, now I will share the PDF version of these tudes in the group. I will share it. If you require these tudes, right, you have to separately want to request and you want to purchase them. That story. Okay, story is okay. Story is okay. Then summary very simple. Summary is very simple. Okay, very simple. Right, already we started our classes and 2028 batch class online. Online is smoothly going the classes. So this week to Wednesday 6 p.m. we are starting projectile motion. Right, in recap classes I am going to cover these 6 chapters. Plan of conduct recap classes maximum 2 months. By the end of August I will completely finish all these chapters. I don't post these tudes. These tudes I don't post. I will share the PDF version of those tudes. If you want the hard copies, if you want to post the tudes, then you want to do a kind of separate payment for that story. But our current class, ongoing class tudes, fully free. So we are posting all the ongoing class tudes free of charge. We are posting to your home. That story. And also next point is we are started our paper classes also. That is happening on every Monday. It's a permanent time. Every Monday 9 p.m. to 11 p.m. we are doing. Upcoming days that becomes 8 p.m. to 11 p.m. 7:30 to 11 p.m. Somehow Monday evening time is dedicated for the paper class. That story finished. Okay. Right. And next important thing is you are not late actually. Right, you are not late. We have enough time. You can cover the previous sections and you can come back with a kind of strong feeling. You can start working. Don't worry. I will guide you. If you have any doubt, you can talk with me. You can put a message and you can ask and clarify your doubts. If you have doubts, you can put in the group also. Normally, we are conducting kind of Zoom session to clarify your doubts separately. So you can unmute and you can talk. If not, if you don't like to unmute, what you can do in that separate session, not theory class time. Not theory class. Theory class time, you can ask your doubts via the Zoom chat only, right? Because if you unmute and if you talk, sometimes it's a kind of disturbance for everyone who are joining for the classes. But we are having kind of dedicated, separate Zoom sessions to clarify your doubts. In that session, you can unmute and you can talk. If not, you can put a message, whatever the way you prefer, you can ask your doubts and you can clarify it. That story. And also anytime you can put a WhatsApp message also if you have any doubt, but suddenly sometimes I don't reply, I take some time to reply, somehow you reply. Okay, all good, give me small thumb, all okay sir, give me small thumb, all okay, all good, give me small thumb. All okay, we understood what the story clear, what you explain, idea clear and idea okay, right, okay. Now what I want to tell you is keep a motive and you are somewhat late than others. Right, all your other colleagues, your friends, they started the journey 4 months before, but you are starting the journey 4 months after they started. Therefore, you should work somewhat faster than others. If they are working for 2 hours per day, you want to work at least 6 hours per day to catch the previous lessons and to catch the current lessons and to go. Okay? Right? I will teach you all the current lessons also properly. You will understand. After I finish teaching linear motion, you can understand this current lesson also. I will teach in that way. That way, trust me. Trust me, story finished. Story finished, that's all. That's all. Now, if I share the PDF of dimensions, right? If I share the PDF of dimensions, I will share the PDF right now. If I share the PDF, we'll start the lesson now. If you are having doubts, ask. We'll start the lesson now. Dimensions, and today we are starting linear motion. Right, we'll take first 45 minutes, first 1 hour for the dimensions. The next 1 hour we'll take for the linear motion. I will share the PDF first of those tunes. You have to manage the tunes only. Right, you can take printouts. Okay, now not today. I will upload the recording also on the website. And next thing is you get the recordings free of access. Okay, there's a website. There is a website for my website. The website today this recording will be uploaded tomorrow. Tomorrow you can access the recording. But recording is the expiry date. Therefore, before that expiry date, you want to watch the recording and you want to cover it. It's up to you. You can join live. That is the best option. Joining live is the best option. Worst scenario, if you're very sick or if you have a kind of very urgent, important meeting, something, in that case, you can watch the recording and we'll cover it, okay? That story is okay. But the best option is join live, okay? Join live. Therefore, this class is one of the perfect class to learn physics properly, right? Learn physics properly. Next story is in this our classes now, even though theory class is on 1 day currently, right? Our upcoming days you will understand we are starting paper class early. We started today we are starting paper class. Likewise, paper class we are discussing 35 years of past papers and model papers. Not only that, we are starting some essay booster classes, and we will start kind of hint sessions, right? Likewise, doubt clearing sessions. Likewise, in addition to theory class, we are doing so many extra sessions in night times, and right, we are doing on behalf of students. Therefore, I don't think anyone at any level who come to my class, definitely they can grab something for sure. Therefore, you'll understand. And also my qualification is, if I tell briefly, if you don't know, right, I'm a graduate from University of Moratuwa, right, I did mechanical engineering. I have a class in that mechanical engineering degree, and actually I am working as an engineer currently. Right, I have worked in 3 multinational companies. Right, one is you'll know Unilever. Then I worked in Nestle, and then currently I'm working in Fonterra. Right, parallelly I'm teaching these. That's the story. That's my education background. That's all. I think that is more than enough to teach. Right, that is more than enough to teach. Story is okay. Right, okay. I'll share the PDF in the group. We'll start dimension story. Meantime, if I get something to tell, I will tell you in between. Time is 5:24. We start the class at 5 o'clock. Won't stop the class at 7 o'clock. Because I have another class at 7 o'clock. Right, okay. If I share the PDF. Now everyone stay focused. Take a CR book right now. Take a CR book. I will share the PDF now. If you don't require any hard copies, what you can do, you can take a printout of those PDFs and you can manage it. But ongoing class tunes, I will post you, don't worry, okay? Right, if I share the PDF, okay, right. If I share the PDF, but remember, if you miss these sessions, right, again, you have no option to cover this story, okay? In 2027 batch, there are so many students, they are still struggling, sir, because we could not cover the initial sections in mechanics and unit 1. Still, we can't understand the current lessons. Therefore, don't be one of them. Right? Therefore, join live and cover it. Okay? Join live and cover it. Okay. All right. Then if I share the PDF. Right? Yeah. Okay. Any doubt, ask. Anything you can ask. Right, I share the PDF in the groups. Okay, shared. Right, go to the page number. In the PDF, go to the page number. Right, page number. We'll talk about dimensions first. Right, go to the page number. Okay. Page number 10. Page number 10, dimensions. Go to page number 10, dimensions. Okay, story. Right, story, right, I don't reduce the content, same content I delivered to the previous classes, 28 batch, same content I'm delivering, but somewhat fast, okay, right, dimension story. It's a new section. I think you never learned in all levels also what is dimensions, you never learned, I think. Very first time only you are learning dimensions, if I can remember. All right, dimension section, unit 1, story, right, okay. Dimensions. Normally I explain units and then only I teach dimensions. But it's okay, we can give priority for dimensions. Dimensions. Now, what does it mean by dimensions? Before dimensions, everyone want to understand what are physical quantities? Physical quantities, because in our physics subject, I don't do an introduction, can't do an introduction, we have very limited time, right? In this lesson, this physics subject, throughout the lesson we are talking only about the behavior of physical quantities. Right, now what is physical quantity? Can someone explain? If you have an idea, all levels also you learn science subject. Under science subject also you learned about physical quantities. What are physical quantities? Any idea? Physical quantities, any idea? Physical quantities, any idea? Everything I write in the whiteboard, you can write down. Physical quantities. Physical quantities. What does it mean by physical quantities? Quantities. Okay. Now, can someone tell what does it mean by physical quantities? Any idea? Any idea? What we tell the story. Right, in our universe, in our environment, we know that there are so many changes happening in the universe. Around you, around the environment, you can experience, you can observe, there are so many changes happening in the universe. If you can observe a change and if you can measure that change, if you can measure that change, maybe qualitatively or quantitatively, if you can measure a change, and if you can give a name for that change, that is what we call as physical quantity. What is that? In the surrounding, whatever the changes happen in the surrounding, if we can measure it, and if you give a name for that change, that is what we call as a physical quantity. For an example, you all know that currently now you are observing me. I'm a human. Right? Currently now, when you keep on observing me, you are noticing. Now when I'm walking, you are noticing that something is changing, right? When I'm walking, you all know that you are noticing something is changing, right? My location is changing, right? You notice my location is changing. If I'm walking, my location changes. You can measure the change of my location, no? If you give a name for that change of my location, what would be the name that you give? Reply. If you can give a name for that change in my location, what would be the name that you will give? Reply. That is what we are calling as displacement. If not, you can think like distance in the beginning, the displacement, distance, right? And next story is, now if there's a water bottle, that bottle is initially completely filled with water. Now I am drinking water. You are observing the water bottle, not me. You are observing the water bottle. when I keep on drinking the water, you are noticing something is changing in the water bottle. Right? If you can give a name for that change, what would be the name? If I am drinking water continuously, you are noticing initially water bottle is completely filled. When I keep on drinking the water, you are noticing, you are observing the water bottle, something is changing inside the water bottle. What is that something? That is, if you give a name for the something, if you give a name for the something, what is that? That's going to be volume. That's going to be volume. That's going to be, someone can tell, that's going to be mass. Likewise, this is we are calling as physical quantity. Every change happening around us, if we can measure it, and then if you can give a name for that change, that is we are calling as a physical quantity. So then mass, length, time, volume, distance, displacement, velocity, these all come under physical quantity. Clearly, these all come under physical quantities. What we are doing, take your notebook and write a story. Okay, some stories I will tell in the tude. Some stories I will tell you to write in your notebook. Take your notebook and quickly write down topic. Main topic is dimensions. Write down subtopic physical quantities. Subtopic physical quantities, we'll write a small definition for that. Subtopic physical quantities, just write down a small definition physical quantity. Write down a small definition. Write down subtopic physical quantities. Write down below. Physical quantity is physical quantity is physical quantity is a quality or quantity. Physical quantity is a quality or quantity. Physical quantity is a quality or quantity which can be measured directly or indirectly. 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 Okay, ni? Idea okay. That story is okay. Simple ni. Right, you can feel it. Hands up, how many of you can feel what is this physical quantity story? How many of you can feel hands up? Just raise your hands. How many of you feel, if I tell what is this physical quantity, raise your hands. How many of you can feel story, hands up? Raise your hands. Raise your hands, we all can feel it, no? The story, we all can feel it. Now what we can do, if I ask you how many physical quantities are there in the universe, if I ask you how many, right? We can't tell exact number. There are so many there are so much of physical quantities. For our convenience, when studying about physical quantities, in our physics subject, entirely what we are doing is studying about physical quantities only, entirely. Throughout this 2.5 years, we are going to talk about physical quantities only. Every chapter we are talking physical quantities only. For our convenience, what we can do, we can divide physical quantities into two subcategories. That is what we are calling as vectors and scalars. Right? We can categorize all the physical quantities into two categories. One is scalars. Other category is vectors. Scalars, vectors. Now, all levels also learn. If I ask you what is a scalar, you all know that there are some physical quantities to describe the physical quantity, to explain the physical quantity to someone, to describe the physical quantity to someone. Only magnitude is sufficient. For an example, mass. Mass is also a physical quantity. Now, when you go to a shop and let's say now if you want to buy a dal, we all know units to measure mass is kilograms, grams. You all know the story. Now you are going to a shop and you want to buy a dal. Your mother is telling, buy dal. Right, you are going and you are going to ask that shopkeepers, you are going to ask from someone, right, I give me 5 kilogram of dal. So when you tell give me 5 kilogram, if you measure the magnitude exactly, 5 kilogram of dal, that shopkeeper, that guy also understands, okay, this one is asking 5 kilogram of dal and he brings 5 kilogram of dal. No issue. No issue, no. To describe that mass, to describe the mass, only magnitude is enough, 5 kilograms. Only magnitude is enough to describe that physical quantity. But there are some physical quantities, right, only expressing, when explaining physical quantity, only mentioning the magnitude is not sufficient. We want to mention the direction as well. For an example, force. For an example, force is a vector. The physical quantities which require, to describe the physical quantity which require magnitude and direction both, then we are calling them as vectors. The best example for a vector is force. This story we learned in all also. Right? Okay, now force. For an example, now, if you want to buy mass, if you want to buy 5 kilogram dal, you are not going to ask from the shopkeeper, I need 5 kilogram of dal upward direction. Do you ask from the guy, I need 5 kilogram of dal to right direction. Give me 10 kilogram sugar in the vertically upward direction, vertical down direction. Do you ask like that? We don't require direction. To explain physical quantity like mass, scalars, we don't require a direction. Only magnitude is enough. But there are physical quantities, the vectors, they require magnitude and direction both required. For example, force, let's say now I'm telling there's a table in front of you. I'm telling my target is I want to move the table to the right side direction. But I'm telling to you, apply a force on, because my intention is I want to move the table right side. That's my intention. But I'm telling you, I'm expressing you the idea, apply 5 Newton. You all know Newton is kind of unit which force me. I'm telling you, apply 5 Newton force on the table. Now what you are doing, I want to move the table right side. Since I just told apply 5 Newton force, you are applying a force on the table to the left side direction. Actually, I want to move the table right side. I told you to apply 5 Newton force. You also applied exactly 5 Newton force only, but you applied left side. So there is a kind of misunderstanding between you and me. That means when I am expressing that force, not only magnitude, I want to mention direction also. Then only the one who understands can understand clearly. So that story also very clear idea. Then category vector, scalars, okay. Vectors means scalars means physical quantities which only requires magnitude. Vectors means we all know that physical quantities which require magnitude and direction both. It require both. Vectors require magnitude as well as direction both. Now write down, now subtopic, okay, example, physical quantity, write down, examples, write down, physical quantities, example. Normally we write the note in TUTE, okay, because especially online classes, we can't write the note in a book, because every time I can't read the note, no, because there may be some connection issues, right, there may be some issues. Therefore, normally we have a TUTE. In the TUTE itself only, the question and the theory note, there are some gaps to write the important theories, there are spaces. Normally we write the note in the TUTE, and all the questions are in that TUTE. But since it's a recap class, what you do, what we can do, we'll write the note in the book. Right, next day you take a printout of these TUTEs. If you want the TUTEs, you can request. Then by the next week you might have to receive the TUTEs. Next week onwards, we'll write the note in the TUTE itself. Okay, no? Story is okay, no? Okay. Vectors means they require magnitude and direction both. They require magnitude and direction both. Right, after writing physical quantities, that definition, write down examples, Give some examples for physical quantities, mass, length, volume. Likewise, give some examples. Write some examples, mass, length, volume, force. pressure, density, energy, power. Write some examples. I'm explaining a little bit faster, not fully fast, a bit faster. Magnitude and direction both. Vectors, magnitude, direction both. Clear me? Now write down below, write down. Physical quantities can be categorized into two categories. Write down. Physical quantities can be categorized into two categories. Right? Don't now when you are taking a session, fully stay in the session. Okay, fully be in the session. Okay, don't plan after class finishes I will study that story. Not in A levels. O levels you normally we don't learn anything in the theory class. We just copy, we just understand, come, and after you come to home only you study. But A level story in that moment when you are in the session itself, you want to study, you want to be in session and learn everything properly. Right? Okay. Write down. Physical quantities can be categorized into two categories. Number one, scalars. Number two, vectors. Number one, scalars. Number two, vectors. Number one, scalars. Number two, vectors. If you're having doubts, ask. Write me story, okay? Then put your subtopic scalars. Put your subtopic scalars. Write down below. The physical quantities which require only magnitude. The physical quantities which require only magnitude. The physical quantities which require only magnitude to express. The physical quantities which require only magnitude to express are called scalars. Highlight scalars topic and only magnitude. Highlight scalars topic, then highlight only magnitude. Then write some examples for scalars. You give some examples for scalars. Now imagine, based on the physical quantities that you can remember, everyone give some examples for scalars. I am telling mass. Likewise, everyone put in a Zoom chat. This is very basic question. Give some examples of scalars. Everyone give a try. Reply to Suleiman sir. Don't reply to Aurex Academy. Everyone give some example scalars. Everyone give some examples for scalars. Give some try. Give a try. Everyone give some examples of scalars. Give a try. Mass, yeah, mass is a scalar. Right, and then we know, yes, distance scalar. Write down. Examples, write down. Mass, distance. Example, write down. Mass, distance. One can write down length, volume, time. Mass, distance, length, volume, time. Likewise, you can explain plenty of examples of scalars. Mass, distance, time, length. They all are scalars. Clearly, write some examples. Few examples. Then put your main topic, vectors. Vectors, write down below. Vectors, write down. Definition. Vectors, definition, write down. Write down. The physical quantities which require both. The physical quantities which require both magnitude and direction. The physical quantities which require both magnitude and direction. The physical quantities which require both magnitude and direction to express. Are called vectors. Clear idea. Highlight vectors. Highlight magnitude, direction, highlight. Vectors highlight, magnitude, direction highlight. What are the examples that you can tell for vectors? Examples you can tell for vectors, yeah, we all know that very popular example for a vector is force. Very popular example. Force. But if I ask from all of you, what are the other examples of vectors? Displacement. We will learn. Today we are learning what is displacement we are learning today. Then velocity is a vector. Acceleration is a vector. Displacement is a vector. Velocity is a vector. Acceleration is a vector. Okay, then you can write down displacement is a vector. I will explain what. If you don't know displacement, don't worry. I will teach you. Today we are learning displacement, then velocity, acceleration. So these all come under vectors. Velocity, acceleration, they all come under vectors. Clear? Right? Okay. Okay. Clearly? Alright, now we understood what is a physical quantity. Then we realized it can divide into two categories like scalars and vectors. We know what are scalars, what are vectors, idea very clear. We know the examples also so far very clear. Right, okay? Right, okay. Clear now? Alright, okay. Next story. Next story, now we'll talk about, based on this idea, now we can talk about dimensions theories. We all know that in our daily life, we are obtaining so many measurements. Measurements of what? In our daily life, right? Even you go on Uber, even you go on Pick Me, right? Let's say now, even if you want to go to a class, if you want to join for the class at right moment, so we all have to take measurements. Right? Now tell me, what are the measurements that we are obtaining in our daily life? Measurements means we are measuring the measurements of physical quantities. What are the measurements that we are obtaining in our daily life? We all know we want to measure length, a distance. The distance from your home to school is 5 kilometer distance. And then we are measuring what? Mass. Even you go to a food city. When you are, if you want to buy sugar, dal, rice, whatever, right? You want to measure the mass, and also definitely you want to measure time. Likewise, in our daily life, you are obtaining so many measurements. Okay, no? Now, right? Okay, no? Now, right, daily in our life, we are taking so many measurements. Okay, no? Clear, no? Right, now next story, right, then what is this dimensions? We know what is measurement ideas. Okay, dimensions means what? Dimensions mean what? That's a story, that's our lesson. Lesson is dimensions. Okay, now this story I told you because this content is important. Right, I can't properly, step by step, I can't properly teach you these ideas. I am prioritizing what is important first. That's how I am covering those 6 chapters. Okay. Therefore, I hope everyone understands this idea, but don't worry. What I taught for this 28 batch, same story, same, and I will teach you for you also. Don't worry about that, okay? Right, now we'll go to the tute and we'll talk about dimensions idea. This story more than enough. We can go to the tute and go to the PDF, page number 10. Page number 10, dimensions idea. Page number 10, dimensions idea. Clear? Page number 10, dimensions idea, right, okay. Okay, right, okay. Now, dimensions idea. Okay, right. Now, if I explain this idea about dimensions, now we are defining, there are 3 core physical quantities. Okay. First of all, we have to understand when you consider all the physical quantities, there are 3 main physical quantities. Right? We require 3 main physical quantities widely in our daily life. What are those 3 physical quantities? Definitely mass, definitely length, definitely time. These are the 3 main physical quantities that we require widely. Right, all the scenarios we require these 3 physical quantities. So what we are doing is, right, there are 3 main physical quantities, that is mass and length and time. Mass, length and time. What we are doing, we are giving a symbol for them. Right? Mass, length and time. Mass, then length and time. What we are doing is, length and time, what we are doing is, if you can give a small symbol for mass, let's say now mass, first letter is capital M. Therefore, what we can do to represent mass, you can give a symbol. Because we all know velocity means what? Velocity means simply likewise. Under dimensions, what we are doing, we are identifying three co-physical quantities, that is mass, length and time. I will explain what is exact dimensions. Under dimensions, we are identifying three physical quantities which are mass, length and time, and we are introducing a symbol for mass, length and time. The symbol is always the first capital letter of that physical quantity. Mass, first letter is capital M. Therefore, we are introducing a symbol for mass, that is capital M. That is capital M. Okay, when you consider length, first letter is capital L. Therefore, we are introducing a symbol for length, that is capital L. Capital L. When you consider time, its first capital letter is capital T. The symbol for the time is capital T. Okay. So under dimensions, what we are doing is we are identifying, we are checking how all other physical quantities other than mass, length and time, velocity, acceleration, displacement, and we all know that in energy, power, pressure, right? There are so many physical quantities, right? So what we are doing is under dimensions, we are going to understand how all other physical quantities link with these three main physical quantities, mass, length and time. What we are going to do is, we are going to understand how each and every physical quantity link with mass, length and time. Simplify till, we are going to understand the connection between a physical quantity with mass, length and time. So we introduced symbols for mass, length and time, capital M, capital L, capital T. For an example, other than these three physical quantities, can you give an example for a physical quantity? Let's take speed. So we all know that speed. So we all know speed. You can remember all levels you learned speed equation. Today I will teach you. But speed equation, you guys can remember what is speed. Speed means we all know that distance over time. Right? Speed is distance over time. Speed is defined as what? Distance over time. Today I will teach you once again story. Distance over time. So now, you are telling under dimensions, what we are doing is, we are going to understand how every physical quantity is linked with mass, length and time. That's what our target. We notice speed means distance over time. So we all know that distance is basically a length, right? Distance is basically a length, right? Distance is basically a length. So therefore we know this speed, this physical quantity speed is linked with length. Am I right? This physical quantity speed is linked with one of the lengths. Distance means what? It's a length. Basically a length. It's a length. It's a length. Distance is basically a length. Okay? It's a length. Distance basically a length, right? Time, yeah, speed means the length over time, distance over time. Length, time. Time is also one of the main physical quantity. So we found speed is linked with length and time. Out of these three main physical quantities, this physical quantity speed that is linked with length and time. So what we are doing, under dimensions, what's our target? We are going to find every physical quantity, how every physical quantity linked with mass, length and time. We realized, for an example, speed that is linked with length and time. No? So we are writing a kind of relationship like this. Distance means length, the symbol for length is capital L, and symbol for time is capital T. So we are writing dimensions of speed is what? Capital L over capital T. Right? We can write down dimensions of, very carefully listen. So therefore we can write down dimensions of speed. Dimensions of speed, that is equal to what? That is equal to distance. Speed is linked with length, capital L. You can put a symbol, capital L. Capital L. Division. The symbol of time is what? Time symbol is capital T. First letter capital T, time symbol is capital T. So now this is the idea. Dimension in our syllabus, under dimensions we are finding what? Dimensions of physical quantity. If you find the dimensions of physical quantity speed, how speed is linked with these three people, speed is only linked with length and time. So you are representing the length and time as symbols, capital L over capital T. So then what is the dimensions of speed? L over T. If you can move this T to the numerator, you will learn in all levels. When you are moving capital T to the numerator, now currently capital T is the denominator. What is the power of capital T? 1. Currently power of capital T is 1. When you move capital T to the power 1 to the numerator, you guys learned, it becomes capital T to the power minus 1. It becomes capital T to the power minus 1. When something is in the denominator, when you are moving to the numerator, the power becomes negative. Capital T to the power minus 1. So we can write down, therefore, dimensions of speed is what? LT minus 1. Do you understand? Therefore, we can write down dimensions of speed. Dimensions of speed. You will understand very simple section. Speed is what? LT minus 1. LT minus 1. Right? So then every time, sir, writing dimensions of something, dimensions of speed, dimensions of volume, dimensions of, really annoying, right? Very difficult, uncomfortable. So what we are doing, we are introducing a symbol for dimensions of as well. Rather than writing dimensions of with words, you can use a small symbol. If you write down, you can use a symbol. Dimensions of means, remember, right? Instead of writing dimensions of, you can use a symbol. Dimensions of, you can use a symbol. The symbol is a kind of square bracket. A symbol is square bracket. The symbol is square bracket. The symbol of dimensions of is a square bracket. You can write down, rather than writing dimensions of speed, rather than writing dimensions of inverts, if you write down speed, look here, inside the square bracket, everyone understands. You meant, if you write down speed, inside the square bracket, everyone understands. Who know physics, they understands. Actually, you are explaining, here you are referring dimensions of speed. You are referring here dimensions of speed. You can write down, if you want, you can write down in words, dimensions of speed, dimensions of volume. It's up to your choice. But rather than writing dimensions of inverts, you can use a small symbol, that is square bracket. When you write the physical quantity inside the square bracket, dimensions of speed, that is equal to what? That is equal to LT minus 1. LT minus 1. LT minus 1. That's all. This idea so far clear, I think anyone understands, right? Shall I do one more story? We all know that, area equation. What is the area equation? Area means we all know that length into width. Area means we all know length into width. Right? Have to stop the class exactly 7 o'clock. Right? Area means we all know that is length into width. Right? Area is what? Length into width. Okay, next equation. Right, equation 1, now I am explaining. In the exam, they will ask you to find the dimensions of area. When they ask you to find the dimensions of area, we all know that area means length into width. Length into width. Length into width. So now, now they are asking us to find the dimensions of area. What is the meaning of finding dimensions of area? We are trying to find how area is linked with mass, length and time. So we are putting some symbols for mass, length and time, and we are checking how this physical quantity area is linked with mass, length and time.
Basically, finding dimensions of area, we are writing the relationship between area, mass, length and time in terms of symbols MLT. So now sir, here length is capital L, length. Width is also a length. We all know width is also a kind of length. So we found, if you want to find the dimensions of area, very simple. If you want to find the dimensions of area now, you can write down area inside a square bracket. Why? Because we know if you write something inside a square bracket, the meaning is dimensions of area means what? What is the dimensions of length? Length is capital L. Length is capital L. Length is capital L into, now width is also a length. So therefore, what is the dimensions of length? That is capital L again. So we can write down dimensions of area is what? L into L. L into L is what? L into L is L squared. So you can write down area dimensions. That is what? Area dimensions. That is going to be equal to what? L squared. Area dimensions L squared. But don't just write area. If you write area, the meaning is wrong. Right? If you want to mention L square means what? Dimensions of area. Definitely you want to write down area inside a square bracket. Square bracket story. Okay. That's all. That's all content. That's all content. Story very simple. Right? Idea okay answer? Raise your hands. How many of you understood this idea of dimensions? Idea answer. Idea okay answer? This idea is okay answer. Very clear sir. Idea is not difficult. We can understand. Very simple story. Idea is clear sir. Idea is okay. Nice story. Very simple story. Right? Okay. Very good. Nice. Very simple story. Very good. Okay. Now what we do? Now do you take your tute? I think today you are uncomfortable. I think no. I should have given this PDF early, but I could not give. Right? If I have given earlier, you could have printed. Then at least you can write the note in the tute. Okay. Write down somehow in that PDF. Take your PDF. In that PDF, we'll refer the note. We'll refer the note. What they are telling in the PDF. What they are saying in the PDF. Page number 10. Page number 10. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent the quantity. Okay, you don't understand the story. Okay, don't worry. It is a symbolic expression. It is a symbolic expression in terms of MLT. This capital M, capital T are the symbols. It is a symbolic expression. We are getting LT minus 1, L squared. These are symbolic expressions that shows how a physical quantity is constructed from fundamental dimensions, mass, length and time. Remember, we are calling mass, length and time as fundamental dimensions. Remember, mass, length and time, we are calling them as fundamental dimensions. Fundamental dimensions. Fundamental dimensions, right? Okay. What is the dimensions of mass? Capital M. What is the dimensions of length? Capital L. What is the dimensions of time? Capital T. Then what is the dimensions of area? L squared. What is the dimensions of speed? L t to the power minus 1. That story okay. Right? One last time I will repeat that sentence once again. If I repeat it, what? It is a symbolic expression. Yeah, symbolic expression only. Yeah. Symbols, no MLT symbols. It's a symbolic expression, L squared, LT minus 1, yeah. It is a symbolic expression that shows how a quantity is constructed from the fundamental dimensions MLT. Very clear, right, okay. And now the three fundamental dimensions, I have given a small table. In the table, what you want to do is, right, now currently you don't have the tute. What you do, take your CR book and write down the table. You have the PDF in the tute, in the CR book, draw the table and write down. Left side dimensions, write down mass, length, time. Right side there are symbols, capital M, capital L, capital T. In the table, under dimensions column, write down mass, length and time. In the right side column, under symbols, write down capital M, capital L, capital T. Once you finish writing, answer. So take your CR book and write the table. Once you are finished, answer. Once you are finished, Once you are finished, hands up. Very simple story. Very simple. Very simple. If you are finished, hands up. Very simple. Now I don't give any break. Normally we give a break, but today don't know any break. We are in the class till 7 o'clock. 7 o'clock. 7 o'clock. 7 o'clock. Finished, hands up. Finished, hands up. People who finished, hands up. If you are done, hands up. And raise your hands. Now below the table, there is an important point to be written. I have given a small space. In the space, take your red color pen and write down. Write down. The standard symbol used to denote the, write down, red color pen. The standard symbol used to denote the standard symbol used to denote the dimension of a physical quantity, dimension of a physical quantity, dimension of a physical quantity is square bracket, is square bracket, highlight square bracket, highlight standard symbol, highlight standard symbol, square bracket. Now I have given 3 sample test me questions. Find the dimensions of those given physical quantities on a test me question. Give a try. Find the dimensions of below physical quantities. Area means I have explained. Area explained. Give a small try for volume and speed. Speed also I have given. I explained that story also. Quickly find the dimensions of volume. If you are done, answer. Very basic question. What you do, quickly try that, copy down area. This example write down. This example write down area means length into width. Dimensions of area means L into L squared. Then write down speed. In the question, speed is given as a third question. Speed, the distance over time, L over T, LT minus 1. Then find the dimensions of volume. Anyone can do, right? Then find the dimensions of volume. Right, anyone can do. Once you are done, answer. Once you are done, raise your hands. Once you are done, answer. Right, once you are done, answer. Okay, Neem? Right, okay. Okay, Neem? Time is 6 o'clock. Finished. Finished. So now volume means they have given length into, volume means length into breadth into height. Length into breadth into height. Very simple. Right? Volume equation is what? Length into breadth into height. Length into breadth into height. Now I want to find the dimensions of volume. So volume dimensions. Volume dimensions. So one can write down now. Look here now, step by step, follow what I am telling. Now volume dimensions, you write down here, length, again write the equation. Again write the equation, everyone. Length into breadth into, step by step, follow what I am telling. Length into breadth into height. Now what you do, please, now if you are finding, this is an equation. When you are finding dimensions of volume, right, you want to put the dimension symbol for every physical quantity. So put dimensions of length, dimensions of breadth, right, dimensions of height. Definitely you want to put for the every physical quantity in that equation this square bracket. The previous 2 examples I didn't explain like that because it's I'm explaining from the beginning. No? So but hereafter what you do as a practice, if they have given an equation for the every physical quantity, please write the square bracket. What is the meaning of that? Dimensions of volume equals dimensions of length into dimensions of breadth into dimensions of height. That's the meaning. So length dimensions capital L. Breadth dimensions also, breadth is also a length. Therefore dimensions of breadth is also capital L. And then dimensions of height is also capital A. So we are getting L into L is L cube. L cube. So we all know volume dimensions. Volume dimensions, that's L cube. That's L cube. L cube story. L cube, simple. Simple. Now idea clear. So we know how to find the, now from what you explained till now, very quickly you explained, we understood how to find the dimensions of physical quantities, we know the story. What you do, we'll do a question. Take your tutor, go to the tutor page number, page number 15. Page number 15, start doing. Question number 1, page number 15, the first question, find the units and dimensions. Don't find units, everyone find dimensions of the physical quantities shown below. Start doing question number 1, sub question number 1, it is area we found. Keep on doing number 2, number 3, number 4, number 5, number 6. Everyone start doing question number 1, sub question. Right? Not question number 1, sub question number 1, number 2, number 3, number 4. Sub question number 1, start doing 2, 3, 4, 5, 6. Finished and sub. The remaining homework, start doing question number 1, sub question number 2, 3, 4, 5, 6, page number what? The page number is 15. Page number 15. Page number 15. You try. Anyone can do very simple story. Anyone can do. If I share the PDF, I share the PDF in the groups. Okay. If you finished doing this question, raise your hands. Raise your hands. Raise your hands. If you finished, hands up. Not difficult question, very simple question. These are very basic questions. Very basic questions. I'm doing parallelly. Remember dimensions and linear motion, 2 sections. I'm doing parallelly. Okay, parallelly I'm doing. Because I want to somehow bring everyone into the track for the current lesson, right? But don't worry, I will explain everything properly. That's my responsibility. You join live and you cover it. You join live and cover it. That's it. That's it. I'm also doing. If you finished, hands up. Once you are done this story, raise your hands. But in the beginning, my advice is don't be hurried to get the final answer. In the beginning, what you do, step by step, follow all steps and just do and get the answer. In the beginning, you don't be very hurried to get the final answer. Better if you can quickly finish it, really better only. But give priority in the beginning to do something clearly and properly by following steps. In the beginning. In the beginning. Right? So then if I start doing question number 1, number 2. Number 2 is velocity, that is displacement over time. The velocity equation is displacement over time. Right? Velocity equation is displacement over time. Sometimes you have problem. Displacement is basically a length. Remember, a velocity equation. The given equation is what? Velocity that is equal to displacement over time. Right? Displacement over time. Displacement over time. Displacement over time. Right? So now, if you want to find the dimensions of velocity, what you do, please write down all these physical quantities inside the square bracket. Write down all these physical quantities inside the square bracket. So once you can write the equations, okay. One can write down the same equation, this equation, one can write down the square brackets, okay. But in the beginning, when you are following steps, better. So write down once again velocity. Velocity is equal to what? Displacement over time. It's really annoying, but what to do in the beginning? Follow all steps. Displacement over time. Displacement over time. Displacement over time. So we want to find the dimensions of velocity. That means dimensions of velocity square bracket. If you write down velocity inside a square bracket, the meaning is what? Dimensions of velocity. That is equal to what? Dimensions of displacement. Write down displacement inside a square bracket over dimensions of time. Dimensions of time. Clearly? Clearly? So displacement is also basically a length. When you see these are the three fundamental dimensions, mass, length and time, capital M, capital T. Displacement is basically a length, therefore capital L. Dimensions of displacement is capital L. Capital L over what is the dimensions of time, that is capital T. Time dimensions capital T. Capital T over capital T. So now capital T is in the denominator. What is the power of capital T? Power of capital T is 1. If you move capital T to the power 1 from denominator to numerator, it becomes what? Capital T to the power minus 1. Therefore, we can write down velocity dimensions LT minus 1. LT minus 1, simple. Number 3, acceleration. Number 3, acceleration, that is what? Velocity over time. Acceleration means we all know velocity over time. Right, acceleration, that is equal to what? Velocity over time. Velocity over time. Velocity over time. Velocity over time. Right, if I want to find the dimensions of acceleration, right, we can write down. Okay, right, you guys, okay, acceleration means okay, acceleration means velocity over time. It's okay. Velocity over time. Velocity over time. Dimensions of acceleration means dimensions of velocity. Dimensions of velocity over dimensions of time. Clearly? So now what is the dimensions of velocity we found? We found dimensions of velocity means L capital T to the power minus 1. L capital T to the power minus 1 is the velocity dimensions. L capital T to the power minus 1 division dimensions of time is capital T. Capital T. When this capital T goes to the numerator, that becomes what? Capital T to the power minus 1. Capital T to the power minus 1. Already capital L into capital T to the power minus 1 is in the numerator. There is another capital T to the power minus 1 in the numerator. When you simplify, then what is the answer? We all know that O-level science, O-level maths you learned, if you can add the powers. Right? Same base means. Now capital T minus 1 into capital T minus 1 means same base means you can add their powers. Minus 1 is how much? Minus 1 is minus 2. Minus 2. We can write down the answer is what? Acceleration dimensions capital L, capital T to the power minus 2. Minus 2. Simple idea. Next story. Number 3, number 4, number 5, number 6. Then story finished. Right? Now thereafter, now you know what is dimensions now. Thereafter I will start parallelly explaining vertical motion, linear motion theories. Next story. Next story. Then next one is what? Force means mass into acceleration. Number 4, force means mass into acceleration. Number 4. Force means what? Force equals mass into acceleration. Mass into acceleration. Mass into acceleration. Mass into acceleration. Nice. I want to find the, but you please write down the equation once again by yourself, okay? Like this, write the equation, once again equation write down, then put the square brackets, then find the dimensions of that physical quantities, okay? I'm lazy. Because I'm lazy, I'm writing this equation itself, dimensions of force. You guys don't become easy. You guys don't become lazy. Dimensions of force equals what? Dimensions of mass into dimensions of acceleration. Acceleration. Clearly? Clearly? Right? That's clear. Then what is the dimensions of mass? That is capital M. Mass dimensions capital M. Mass dimensions capital M. What is the dimensions of acceleration? Acceleration dimensions we now only found capital L, capital T to the power minus 2. Capital L, capital T to the power minus 2, that is the acceleration dimensions. We can write down finally, sir, force dimensions ML, capital T to the power minus 2. Simple. Capital M, capital T to the power minus 2. That's it. That's it. That's it. Number 5. Number 5, then 5 is what? 5 means pressure. Pressure means force over area. Pressure equals what? Pressure equals force over area. Pressure equals force over area. Hands up who fully done. Question number 2 to 6 hands up. Very simple, very really simple story. Fully done, 2 to 6 hands up. Fully finished hands up. Fully finished hands up. But be in the moment, okay? Be in the moment and enjoy and do it. If not, can't. Right? Don't think, right, no need to do right now. We can do later. No, the story we learned already. Right? If you think like that, don't come. Right? Be in that session and till the last moment, actively stay and do it. That's all. Hands up, finished hands up. Till 6 hands up. Till 6 hands up. Some people, they don't want to raise their hands. Some people, they want to follow everything we tell. Don't be like that. In the beginning, follow what it says and keep on working. In the beginning. Right, sometimes getting an answer for this question is a very basic stuff. Right, sometimes O levels you learned, sometimes very complex calculations. Right, therefore, some people think like, yeah, I finished also, no one raise the hands, but don't be like that. If you finished answer, even the small thing, and even the basic question also, if you are done answer, that's good. That's how we have to keep the interactive feeling in our online class, no? If not, how we can keep the interactive feeling? I am telling something, I am blabbering something in the whiteboard and, right, I don't see your faces, right, I don't see anything, I am teaching in front of a camera, right, how do I understand whether you understood though? You don't understand. Everything is based on the number of people who raise their hands, right? If no one raised their hand, if I ask you all, okay, do you understand? If no one raised their hands, 1 second I'm explaining, 1 second I'm explaining. But not every time it's explaining, maximum 3 times explaining. Okay? Right, okay, story finished. Okay, we'll start the now. Right, parallelly we are doing dimensions and linear motion, parallelly we are doing, okay? Now today we got the idea, what does it mean by dimensions of physical quantity, ideas, clearly, ideas, okay? Right, okay, but there are so many stories in dimensions also. Next we want to talk about dimensional analysis. There are so many stuffs in this lesson also, don't worry. I will teach you properly, A to Z. A to Z, I will teach you. Then force dimensions, that is we found capital M, capital L, capital T to the minus 2. Force dimensions. Force dimensions. Capital M, capital L to the minus 2. So area dimensions also we found. Area dimensions, that is capital L squared. Look here now. Look here now. Area dimensions capital L squared. Capital L squared. Right, then what we can do? Numerator also there is capital L. Denominator there is L squared. You can cancel out 1 capital L. 1 capital L. Then there is only 1 capital L remaining in the denominator. If you move the numerator, that becomes capital L to the power minus 1. So we are getting the final answer, capital M, capital L minus 1, the capital T to the power minus 2. The last story. Number 6, then I will stop explaining dimensions for today. Next day we are talking remaining story. Now I am giving priority for linear motion. Okay, then number 6, density means mass or volume, last one, number 6, remaining homework, density means we all know mass or volume, don't worry, these equations I will teach you in upcoming chapters properly. Mass or volume, So then I want to find the dimensions of density, that is equal to dimensions of mass over dimensions of volume. Mass dimensions we all know, that is capital M. Volume dimensions we found actually, that is volume dimensions we know it's L cube, capital M over capital L cube. So when this L cube, the denominator, comes to the numerator, it becomes capital L to the power minus 3. Right, therefore we can write down dimensions of density is capital M, capital L to the power minus 3. That's all. That's all. Clearly? Generally hands up. Okay, summary stories. In the beginning you start explaining about, you start the lesson by explaining physical quantity. Physical quantity means nothing but any change happening in the surrounding. Any change happening in the surrounding, if you can measure it, and then if you give a name for that change, that is what we are calling a physical quantity. Best example, mass, length, volume, time, temperature, pressure, blah blah blah. Right, for our convenience, we can categorize physical quantities into two categories. One is vector and scalar. Vectors, we know what is the idea. They have magnitude and direction both. Scalars, they only have the magnitude only. Examples, we know that. Then we suddenly start explaining dimensions. What is the core idea about dimensions? Dimension is nothing but we are defining three fundamental dimensions. Mass, length, time. Their symbols are capital M, capital T. Now what we are going under dimensions, what we are doing is, we are going to check one by one. We are taking every physical quantity and we are going to check the link between that physical quantity and mass, length and time. So we can write down kind of symbolic expression in terms of capital M, capital L, capital T for each and every physical quantity. That is what we are calling as dimensions of that physical quantity. We did some examples, story okay. Right, time is almost 6:25. We can do till 6:55. Generally hands up dimensions, we haven't completely finished dimensions. We give a small startup. Then next day we can complete dimensions. Next day theory we can complete dimensions. We have to talk about dimensional analysis, somewhat complex story. Right, till now every story very clear hands up. 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 Very clear hands up. Okay, so then what you want to do is homework in that PDF remaining questions. There are 22 questions in question number 1. We have done only till 6 no. The remaining question till 22 homework. Till 7 to 22 homework. Today itself do it. After class finishes, today itself do it, okay? Today itself do it. Today we have a paper class also, right? Sometimes if you are joining new, if you never learned these stories before, then sometimes you don't understand today's paper class 9 to 11 p.m. But if you want, you can just join and see. If you want, you can just join and see if you want. Okay, no? Right, okay. Next story, linear motion story. Right, remember, you need to, linear motion, you need to. Parallelly, I will do 2 lessons. Then we can finish quickly. Right, okay. Linear motion story. I will complete everything properly, don't worry, okay? You don't keep a doubt with that, okay? Linear motion story. Okay. I will share the PDF of linear motion tute also. Right, so far I have given how many tutes? I have given basic match tute. Basic match tute so far. And then after basic match tute, I have given units and dimensions tute. The PDF I shared, units, dimension tute, one single tute. Then after that vectors, one complete tute, vectors. Vectors is one complete tute, vectors. Then measuring instrument, vernier caliper, micrometer, spirometer, one tute. Measuring instrument, one tute. Measuring instruments, I gave one single tute. Measuring instrument, one single tute. I posted. Then vernier caliper, micrometer, spirometer, those 3 practicals are including under measuring instrument. Then I posted what? Then that's all. Then linear motion and vertical motion, one tute. So this week we are posting the July month tute is projectile motion graph, relative motion, one tute. Also we posted Parsifal book. We posted Parsifal Pro 1. Passive Pro 1 is black color tute. Black color tute, Passive Pro 1 we posted already. Passive Pro 1 already we posted. So this month, this Theory Tute 10, I am posting one Passive Pro Tute number 2. Passive Pro 2 number 2. Passive Pro number 2. Along with that, all the file covers and all we post it. Okay, no? Right. So I will share the PDF version of these tutes. You can take a printout. These tutes I will post you free of charge for everyone who are enrolling for July. These tutes I will share the PDF. You can take the PDF. You can refer it. If not, if you want to take the printout, you can take the printout. If you want to purchase separately these, if you want to get posted these tutes also, you want to request. Okay, no? Right. If I share the next story, vertical motion theories. I'll share the vertical motion theory. Okay. Right. Vertical motion theory. Okay. Sorry, linear motion. If I share the PDF, right. Time is 6:30, maximum half an hour. Maximum 25 minutes maximum. Then story finished. Today class, then effective also. Effective only. Because we are going to cover 4-month theories within 2 months. Okay, I shared in the groups. In the groups I shared, yeah, shared. I share the next tute also. Now, anyone can do this journey. Anyone can definitely get 3 A's. You're not late. And don't think about your all result as a barrier to do A levels. There is no link between all result and A result. Right? Even you get, let's say now 9 A's for your all levels and you are planning to do A levels, math science, completely all right. There are so many people we can tell as examples. We can tell as examples who got 3 A's. Sometimes even they don't have. Any single A or B or C for their all result. Right, therefore, there is no link between all levels, A levels. Only one is important. If you are doing A level math science streams, only one is important. Commitment. You must love it. You should have patience. Patience is very important. Right, commitment, you must love it. You must be very patient. You must fully committed. Unconditionally, you want to work. Fully committed one, you should be. And you must be very interested to learn something new. Right? You should not a person like at what time starting the class, at what time finishing, when sir is doing more than 2 hours or 3 hours, or when will the class will finish, we are feeling tired, we are yawning, right? We are uncomfortable, we can't focus beyond 3 hours, we can't focus beyond 4 hours, no, head is paining, neck is paining, stomach is paining. If you can't tell those stories. If you are doing it, just think about whether you have those qualities. In case if you realize no, you have no that qualities, immediately, not too late, shift to the other streams. Definitely commerce, arts, text lessons, jump it. Right? If you are planning to do math science subjects, remember one story, based on all result, don't conclude about yourself whether you are eligible or not eligible. Right? You want to think the requirements. If you are doing A level, number 1 requirement is fully committed, fully interested. I love this math science subjects. I love it. No, I'm okay, sir. No matter even you put 24-hour class also, I'm okay to stay in the class and without missing any single point, I will fully focus. I will do. I know it's tiredful. I know something will happen the next day once you come to the class, but still I can fully focus. If you can fully focus, right? If you have a patience, sometimes suddenly in this A level, sometimes we are learning complex theories, very complex theories. Right? Sometimes there are some people who don't understand something, they fully give up and they go and they sleep. They don't even want to study once again. If you are that type of guy, not suitable. You should have a very big tolerating power. Right? If you don't have the tolerating power or if you are not that much patient, don't do A-level maths and subject. Quickly jump to the other streams, definitely you can survive. Right? In case if you failed, in case your marks is getting lower, in case if you don't understand a point, if you are a person who easily become fed up, then can't do the story. Right? If you are not a person like that, definitely do A-level math science subjects. If you love it, do it for sure. Definitely you can win. Definitely you can win. Okay, no story. Okay, next story. Next story, vertical motion theories. Sorry, linear motion theories. Linear motion idea. Okay. Right, okay. Right. Okay. So we have around 20 minutes. Okay. Right. Now you want to understand, right, can understand rest and motion. If I ask you, right, people, they don't know what does it mean by rest and what does it mean by object under motion. People, they don't know what does it mean by object is at rest and what does it mean by object is under motion. Right? If I ask you, you guys also can't answer. Linear motion. Linear motion. First, we want to understand, before talking about linear motion, before understanding about what is linear motion, we want to understand what does it mean by object is at rest, what does it mean by object is under motion. Rest and motion. What is the meaning? Rest and motion. Can someone tell me now what does it mean by an object is at rest? And can someone tell me what does it mean by object is under motion? What is the meaning of them? Can someone tell? What is the meaning? With your words, can someone explain the story? Remember, if the position, look here, my position, currently you can see this is my position. With the time, now in the beginning, when t equals 0, the time is, if you have a stopwatch, when stopwatch shows 0, this is my current position. Okay, no? Now the time is running. Stopwatch time is 1 second, 2 second, 3 second, 4 second, 5 second. The time is running. When you look at, when you observe my position, the time is 2 second, this is my position. When time is 0 second, my position was somewhere here. The time is 3 second, now here is my position. When time is 4 second, now here is my position. When time is 5 second, this is my position. So you notice with the time, my position changes. If you notice an object's position changes with the time, then we are calling that object is under motion. Clearly? If you notice an object's position changes the time, then we are calling that object is under motion. Now you are noticing, you are observing me, the time is keep on running, time is keep on going, 1 second, 2 second, 3 second, 4 second, 5 second, but you are noticing my position remains same. I am not moving. You see my position remains same even the time runs. Then you can tell I am at rest. Right? You can tell if the position of an object remains same even time is passing, you can tell that object is at rest. That is the first understanding you have. Clearly? Now if I ask you one question, are you very sure? Right? The story, let's ask from everyone, raise your hands. Okay? People who tell yes or no, raise your hands. I'm going to ask you one question. Sir explained, when you consider an object, what does it mean by rest? If the position does not change with the time, that is what we are calling as rest. If the position changes the time, that is what we are calling as motion. Motion. I'm asking you one question. Now currently I'm standing in front of you. I'm standing in front of you. Hands up, how many of you say, I am exactly at rest hands up. Now currently I'm standing in front of you. Raise your hands, how many of you say, I am exactly at rest hands up. So you are exactly at rest. Everyone, most of you say that Most of you say, currently, now when I'm standing in front of you, everyone say that I am exactly at rest. How many of you say that? No, sir. No, you are under motion and no, sir. Even you are standing, you are under motion and even you are standing, you are under motion and there are some people telling I am under motion. Remember, actually you can't exactly tell. You can't exactly tell I am at rest or you can't exactly tell I am under motion. The reason is you can wonder, what do you mean? We don't understand what you are telling. So we don't understand what you are telling. Right? When you're standing on the ground, you are at rest, no sir. When you are standing on the ground, you are at rest, no sir. Then why you are telling you are under motion? Yeah, when you are standing on the ground, some people told, I am at rest. But if you zoom out this scenario, the person standing on the ground, if you can zoom out, you notice, basically, this person is standing on the earth. We all know this person is standing on the earth. We all know that this earth is revolving. Earth is under rotational motion. Right? Then if I draw the person, when the earth is revolving, look here, the person. When the earth is revolving, look at the person. This earth keeps on revolving, keep on rotating around itself. Then you notice that what will happen for the person? Person seem like under motion. Right? Relative to the earth. Alright, okay. Right? Clearly? Right, this is one story. So what I want to tell is, some people think like, if I ask you what is when someone is standing on the ground, if I ask you what is the state of motion, some people tell, sir, because he's standing, he's at rest, no sir. Yeah, if you think relative to the ground, he is stationary, he is at rest. But sir, when someone is in the planetary system and when someone is observing this person's motion, this person is undergoing rotational motion. Person is moving, person is rotating, sir. Now, can you tell now this person is at rest? According to this scenario, if you are in a kind of spaceship and if you are observing the planet our Earth, when you look at this person's motion, this person is rotating, person is under motion. You can't tell person is at rest. But relative to now, if you are on the ground, and relative to the ground is stationary. Then sir, now you are telling this person is not rest. Sometimes you are telling person is under motion. Sometimes person is at rest. Person is under motion. What is the exact state of motion? Remember. Okay, I will tell one more example. Time is 6:40. One more example. In a bus, right? In a bus, there are two passengers. In a bus, this bus is moving. In a bus, there are two passengers. Passenger A. This one is passenger A. Passenger B. Tell me now, if you are the passenger B, you are inside the bus, right? You are looking at passenger A. If you are the passenger B and when you look at the passenger A who is sitting in front of you, hands up who says, according to you, hands up who says, passenger A is at rest, hands up. If you are the passenger B and when you are look at the passenger A, according to you, hands up who says, passenger A is at rest. Very clearly, according to you, because you are also sitting in front of you, passenger A was sitting, according to passenger B, passenger A is at rest. But now I am, even you are brother, you are sister, Your mother, someone is waiting for you on the bus stand. Someone is waiting for you on the bus stand. Your class finishes, right? Your mother or father or brother or sister is waiting for you on the bus stand. According to that mother or father, what can you say about passenger A? Passenger A is under motion. According to you, passenger A is at rest. According to your mother, passenger A is under motion. The problem is, tell me, seriously, passenger A is at rest or passenger A is under motion? We can't exactly tell, sir, because all the motions in the universe are relative. We can't exactly tell an object's exact state of motion. All the motions we can describe relatively only. Sir, relative to the ground, if relative to the ground, person standing on the ground is at rest. We can't tell exactly, absolutely, person is at rest, we can't tell. Relative to the ground, yeah, person is at rest. Relative to the planetary system, this person is moving in a motion. So relative to B, person is at rest. Passenger is at rest. So relative to the mother, passenger is under motion. So you want to understand summary, very simple. We know that. What does it mean by rest? Position remains in the time. What does it mean by motion? Position changes with the time. Right? But rest and motion both are relative terms, not absolute terms. Clearly? Idea okay? Story okay, right? Okay. Now, in the tute, I have mentioned there, write down, you write in your CR book and manage today. Write down, now I mentioned there, rest, an object is said to be at rest. Write down, if it does not change its position with respect to. If it does not change its position with respect to. If it does not change its position with respect to. Its surroundings with time. Its surroundings with time. Okay, I have given example, a book on the table. Relative to table, book is at rest. Clearly? Now motion, under motion I have mentioned the attitude. An object is said to be in motion, comma, if it changes its position, write down. If it changes its position, write down. If it changes its position with respect to its surroundings. 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 With time. Okay. Now under important I mentioned there, under important write down in front of important. Red color pen, rest and motion are relative terms. Rest and motion are relative terms. Rest and motion are relative terms. Okay. I have given some examples. Those examples I explained here. Now write. Okay. Now we can talk about motion. Hereafter, in our syllabus, entire syllabus, we are going to talk all the motions. Relative to whom? Reply everyone. In our syllabus, we are going to describe all the motions, all the objects' motions, relative to whom? Reply everyone. In our syllabus, we are going to talk about motions of all the objects, relative to whom? Reply everyone. Relative to whom? Relative to the earth. So in the tute, write down in that given space. In the tute given space. Okay. In the dude, go to page number 1, the last point, red color pen. Page number 1, last point, red color pen, write down. Under this chapter comma, all the motions are studied. Under this chapter comma, all the motions are studied relative to the Earth by assuming that Earth is at rest. By assuming that Earth is at rest. All right, 650. Okay. Now we give a small start to dimensions and linear motion. Right, okay. Now we can talk about hereafter distance, displacement, velocity, acceleration. What are those we can describe? That's our plan hereafter. Thereafter, linear motion equations, that's all. Right, don't worry, I will teach you everything properly. You come daily, join live and cover it. Right, then we have night 9 p.m. paper discussion session is there. Right, and Wednesday we have theory class is there, projectile motion. Right, everyone want to join. Don't worry, I will teach you calmly, slowly. Anyone can understand, don't worry. Parallelly, I will teach you the midsections. Some more linear motion I am prioritizing because current lesson is linked with linear motion, not with units, not with vectors, right? Not with measuring instruments. Therefore, if I can explain till acceleration, you can understand projectile motion also very easily. But it's okay. Join the class within 2 weeks. Within 2 weeks, definitely you understand all the current lessons very clearly. Trust me. Right? Give me within 2 weeks. Next week can give 1 more week. Okay, next week may be possible. Within 2 weeks, you will understand current lessons for sure. Trust me, you can understand. Not to fear. Current lessons we haven't covered previous sections. Can we understand? I am reducing the bridge. I'm reducing the gap between them. Don't worry. Right? That bridge I will clear it. You don't worry. Okay? I will guide you properly and do it. Okay. Now 7 o'clock I have a class. Therefore I have to stop for now. Genuinely hands up. Right? Normally we used to do the class from 3 to 5. We could have done, if we had started the class at 3 o'clock, we could have done till 6 o'clock something. Right, today I planned to 3 o'clock, but there was a problem and could not do. But generally hands up, oral session, right, very effective hands up. Oral session is very effective hands up. Very effective hands up. So then try to complete the note in that PDF. You can take a print out if you want. If not, if you have a tab, you can write the note in the PDF itself. If not, if you need the dudes, you want to reply and you want to purchase separate of the dudes. Okay, the best option is take the printouts and do it. This month dudes I will post to everyone. Okay, no, right? Okay, then we are meeting today night. We are meeting 9 p.m. to 11 p.m. If you want, you can join. But I don't think most of you understand. Right? I don't think you can join just for a fun. You can join today, night 9 p.m. This Wednesday class 6 p.m. Everyone want to join. That is our main theory class. Permanent theory class time is Wednesday 6 p.m. to 10:30, 11, don't know. When you start the class, we don't know at what time we stop also, we don't know actually. Because we have that much big syllabus to cover. Wednesday, everyone want to join at 6 p.m. Then story finished. Study well, believe yourself. That is important. Right, when you decided to do something, till you win that journey, believe yourself and keep on working. That's all. Then have fun. Then see you on today night or Wednesday evening, finished class. If you have any doubts, you can reply. You can put a WhatsApp message. If you want to ask something, you can put a WhatsApp message anytime. Then see you. Good night.